Welcome to the Level 1 video on matrices. To start off with, we're going to define compatible matrices. And let's start off by defining what they are. So definition: two matrices are compatible when they have the same number of rows and columns. And this brings us to our next subsection on adding and subtracting matrices. Okay, and in order for us to be able to add and subtract matrices, they need to be compatible, so they need to have the same number of rows and columns. So A, B, C, D plus E, F, G and H, and these two are compatible because they both have two rows and they both have two columns. We just add up the individual entries here, so we have A plus E, B plus F, C plus G, and D plus H. So that's matrix addition and subtraction. Now we can move on and talk about matrix multiplication. So we have two types of matrix multiplication. We have what we call scalar multiplication. That's where we have a scalar, say P, multiplied by the matrix A, B, C, and D, say, and we just multiply each individual entry by that scalar. So we'll have P times A, P times B, P times C, P times D, and it doesn't have to be 2 by 2 matrices. It can be a scalar can multiply any size matrix. And the other type of matrix multiplication is, I'm going to call it matrix multiplication. I know that seems a bit silly, but this is the matrix multiplication most people think of when they think of multiplying two matrices together. So let's review the following sentence. For two matrices A and B, say, the product AB can only be found if the number of columns in the first matrix and this was matrix A is the same as the number of rows as the second matrix. And that was matrix B. And what this means is if we have a matrix A, the first matrix multiplied by matrix B, the second matrix, and this gives us a whole new matrix. If we had defined the number of rows and columns here, so rows and columns by P and Q, and rows and columns by M and N, then this is only possible if Q equals M. So the number of columns in the first one, that's this Q, is equal to the number of rows in the second one, this M. And the number of rows in the first matrix, P, and the number of columns in the second matrix, N, define the size of C. So the size of C is going to have P rows and N columns. And let's do a quick example. Calculate the following matrix multiplication. So just a 2 by 2, 1, 2, 3 and 1, say, multiplied by 9, 6, 7 and 1. And our solution is that 1, 2, 3 and 1 multiplied by 9, 6, 7 and 1 is going to be 9 plus 14, which is the first row of the first matrix multiplied by the first column of the second matrix. And continuing in this pattern, we have 6 plus 2, 27 plus 7, and 18 plus 1, which gives us 23, 8, 34 and 19. And let's do another example. So let's multiply some matrices that aren't compatible. Calculate the following matrix multiplication. And the two matrices are 1, 2, 3, 4, 5 and 6, say, and 7, 8, 9, 10, 11 and 12. And our solution to this, the first thing we want to check is that we can actually compute this matrix multiplication. So we need to check the number of columns of the first matrix, which is 3, is equal to the number of rows of the second matrix, which is also 3. So we can compute the matrix multiplication, and the number of rows of the first one and the number of columns of the second will define the size. So that's going to be a 2 by 2. So it's always worth noting what size of matrix you're looking for at the end. And in the first entry we're going to have 1 times 7, which is 7, plus 2 times 9, which is 18, plus 3 times 11, which is 33. And continuing like this, we get 8 plus 20, plus 36, 28, plus 45, plus 66, 32, plus 50, plus 72. And that's our 2 by 2. And simplifying the individual entries, we have 58, 64, 139, and 154. Thanks very much for listening.